as I understand it, you have all signed up for the 25-cent tour of the key characteristics over the last 10 years. So what I'll do over the next 20 minutes or so is just give you an overview. I want to just start by saying I don't have any conflicts of interest to declare. And what I'd like to do is really talk about what it was like before the key characteristics, which I call the dark years. That may be because at the time I was at the US EPA, I was serving a 10-year sentence, but I did get out 2 years early on good behavior. But I'd really like to focus on what's the progress we've made and what's the promise of the key characteristics, and give a little bit of insight into future prospects. So this is a table that we published with several people who are in the room in a paper that we did in 2009. It was really great. Vince was involved, David Eastman, Martin, and myself. And what this really shows, if I use this, does it work? Is that compared to the number of chemicals that are in commerce, and we could debate how many there actually are or how many should be included in these lists, but compared, if you compare the number of chemicals to the notably public available reviews, you'll see there's actually a very, very big gap. And IARC has done a great job in filling in some of this blank space. I won't comment really on the IRIS program, but it's been a slow progress to really move forward. And some of the challenges is if something hasn't been assessed, does it mean it has no hazard? And how do we choose agents that need to be evaluated? And at the time when I was at EPA being indoctrinated into the methods, we had this mode of action approach. And mode of action was really used for two things. One was ruling out human relevance, and the other one was supporting nonlinear dose response assessments. And it really wasn't a method to help identify hazards. And why is that important is because, as Vince alluded to, really the mechanistic studies and data form the bottom of this food pyramid that risk assessors consume. So this was really a major challenge. And as Vince alluded to also that we did in this paper, when we looked at the human carcinogens, we understood there were really multiple mechanisms that were operative. We heard this morning, Martin spent many years of his life filling in individual boxes on this table, and many other of you did as well, but it was really difficult to figure out a method to go forward. So then came this volume 100 review, and Martin came to DC. He was very, very excited. And I thought, oh, maybe he's had another epiphany, maybe something like the exposome. And he's like, well, he really wanted to talk to me. And his idea was, you're not going to believe it. He believed there was somebody who had a bigger ego than Martin Smith. And I don't know if it was a testable hypothesis, but he put this thing out there, and I was just like, okay, what happened at this meeting exactly? So we've heard some of the stories. It was all very exciting. But really, for the Monographs program and many other programs around the world, there were really a number of challenges that we couldn't search systematically. Tracy Woodruff was leading us into the realm of systematic review, and we just didn't have a way to be uniform across different assessments and looking at this huge mountain of mechanistic data. And working groups began to be very anxious because they thought they were missing things, and they would stumble along and weren't very efficient. And this introduced really bias towards favored mechanisms. So then came the human carcinogens. I think of them as kind of like the top 10 list of what are the properties of human carcinogens. And I've explained this to various audiences, including politicians and lawyers, and people who have no scientific background, and they really understand the first 2 points, that if you know the properties of the things that cause cancer, then the data on those can provide evidence of carcinogenicity for new agents, and they can be used to assemble data without having to know what this particular agent, how it causes cancer. You can just pull together that information. So I put together this timeline of key events. Key events are always very important, but as we've learned over time, key events aren't necessarily causal, but here they are for you to contemplate. It started really with the Volume 100 workshops, and I put in some of the things that happened at IARC across the top. Meantime, there was a lot of publications, there was activity at the National Academies, where I now work, and I'm gonna go through some of these as I go. Many colleagues around the world were involved in these different activities, and I really want to acknowledge everybody's contributions. So I called Martin soon after the meeting, but the publication that Vince alluded to actually didn't happen until 2019. So here we had this great epiphany that did happen, and no one had published on it. And I was very excited because I wanted to use this in this systematic approach. And so I tried to explain this to Martin, that we could have these search terms, and there was just like dead silence on the phone. And I was like, hello, are you still there? And he was like, I have no idea what you're talking about. But I was like, that's fine, don't worry about it. But for people who are involved in reviews, this is really critically important. And we need a way to pull in the information. This is one of the things why we decided to do this publication, which involved Vince and Yvonne, Martin, and many others who are here and maybe on the phone. So, and why did we do this? And I think this slide may actually have come from Michelle, but I credit with Martin where I got it. But this is actually a published adverse outcome pathway or mode of action for benzene, which we heard about extensively this morning. But in our paper, what we showed was if you use the key characteristics approach and bring forward the evidence, it's a much more complicated picture. And so this really allows you to build a credible network that's really based from the ground up, from the evidence forward. So I'll talk next about some of these publications. This was a really nice one that we did, this ToxWatch, and this really great figure that we put together. And I think this was a key step forward because we put the key characteristics into a circle. And this got it out of a priority list, like 1 is somehow better than 10, which may be true, but here they're all kind of in a circle, and epidemiologists have come to me and say, do I have to go KC1, KC2? And I'm like, no, that's why they're in a circle. It's really, they are not in a logical sequence. You can build that sequence if you want to, but you don't have to. And I think this was really helpful for working groups to get out of debating whether the arrow goes this way or that way or both ways, and just bring the evidence to the table and think about it in this construct. And I think that was really helpful. And in the figure, the human carcinogens are in the middle. They aren't all chemicals. I always like to say that. And we have a lot of things like cigarette smoke. Nobody really knows, honestly, how this stuff causes cancer, but we do know that it does, and it's complex, and it involves many of these key characteristics. So we did another nice paper with Yvonne and David, who's here, on these high throughput assays. And this was just another way, if you brought that key characteristics prism, you could actually bring any type of data and put it into these categories. And it was really a great article led by Wei-Shui Chu. And what it really showed, that there are certain use cases where these data are very helpful, but the major limitation is assay coverage, and I'll come to that point again later. So we started using these in the Monographs program where I was working at the time, and we thought, well, after about 8 meetings, well, this would be a great time. We've learned so much, we've done so many different agents. What if we just put together a publication? And this, I had the pleasure to do with the different chairs of the mechanistic work group for each of these monograph meetings. And it was really reflecting on what we'd learned, and could we draw some general conclusions. So one of the things that emerged is that there was a predominance of different cases across evaluations. These evaluations were not selected to highlight different cases, but at the same time, certain key characteristics we really hadn't found evidence for, and that has happened more recently, but it's just kind of the way the cookie crumbles. And oxidative stress came up a lot. So that was another point that I'll also come back to. The other issue is that I think is very important to recognize is that there's a broad literature on the group 1 agents. And there's more, and then as you go down the classifications, there's actually, people don't study this. People get more and more grants to study benzene. It's fantastic, but it's, so your evidence base from the top down is like an inverted triangle, if you will. At the same time, for those agents that were classified, I realize this might be hard to read. You can look it up in the paper, but I'll just go to these main points that for the agents in group 2B or 3, which are under this big orange line, you can see there's a lot fewer X's, and it just, they tended to have maybe one or usually no cases. There were very few human biomarker studies for this particular group of agents, except for welding, which had some amazingly elegant studies, mostly led by David Christiani. The mechanistic data only changed the evaluation for a couple of agents. I love to say tetrabromobisphenol A, because once you say it, like, what could possibly be carcinogenic about that? So, and the high throughput data, again, had little overall impact across these. So around this time, the National Academies emerged with some amazing guidance on this committee, to which Lauren, as well as Yvonne, contributed, and many others. And they opined on the KCs and also gave this idea that the KCs should be applied to other hazards. And I just want to say that through this 10-year process of the cases of carcinogens, the work on the other KCs was just led to a lot of cross-fertilization, understanding different challenges, and here's some of the publications. We'll hear more about this later as well. And then we started to work on this paper. Really was organized by Martin and Mark and others. That was really, how did the key cases relate to the hallmarks of cancer, but also what were the relevant biomarkers and what were the best assays. And I have to say, this was incredibly useful, sitting at IARC and being able to, when you're screening literature, and I didn't have to call somebody like Martin every 15 minutes and going, does this endpoint mean anything about immune suppression? He'd be like, no. Okay. And then 15, what about this one? It's like, okay. So if we wrote it down, it could really, really help screening the literature, but also saying, hey, where do people really focus in your organizational schemes? So then came a big moment for IARC where the preamble itself was updated, and there were a lot of great people who contributed to this. Vince is here, and a lot of great people. Here's Chris Wild who we talked about earlier, and it was really, really a fantastic moment. And Qing Lang is in this picture as well. And what changed really was quite significant for the mechanistic data. We had sort of come up with this 5-step process, and it really came out of the mechanistic data because of that need to sift through so much information. And I'll just kind of describe it in high level, and that we use the cases to identify the literature. And I always have this dream that if you just typed key characteristics of carcinogens into PubMed, everything would come back automatically. Well, that doesn't happen, but it's a good goal. You can still use your filters and help organize your information. And then there's a step where you really evaluate those studies for quality and their importance of the overall evaluation. And I just want to say, these are things that are written in the preamble, especially about concurrent toxicity, thinking about what's the right dosing range, and are the, how are those exposures? Are they chronic? Are they acute, et cetera? And then the synthesis really took advantage of so much of the experience that we'd had, recognizing that some of the cases are more standalone. Others, you really are looking for multiple cases to strengthen the conclusions. And for KC5, which has to do with oxidative stress, there's literally, with caution, unless you really see that in the context of other cases. New classification categories were introduced, and then this concept of how we integrate with the other evidence streams also changed. I just wanted to come back to this quality question because I think we've had criticisms. This is a really, really important point. I would emphasize for people who are more into systematic review, these considerations are really different from what we would term risk of bias, which is really more about the risk that a study is somehow deviating from the truth. But these are the factors many toxicologists, when they're looking at data, would say, hey, I would take a chronic exposure study if I'm looking at chronic inflammation over any other piece of information. And they differ for human studies and experimental animal studies. So in the preamble revision, the strong evidence of the cases can support classifications really through all the different groups. And importantly, it's really a standalone for Group 2B. Now, this had happened before in the history of the program, that mechanistic data had led to classifications, but this really formalized it in this way. So later we had an advisory group convened to look for priorities, and I just would emphasize that the mechanistic evidence was a rationale for prioritizing many agents for either new evaluation or updated evaluation. And one of the things we did, because we had search terms and we could be systematic, is you can actually, if your name is Dinesh Burapal, can basically go to different databases and use these, automatically run these queries to just provide a landscape 10,000 foot view for all these different agents that were looked at. What type of evidence is there across cases? And this is really helpful if you're putting together a meeting and you want different agents to align by the types of evidence they may have, be it human, animal, and what types of cases they may be exhibiting. And that can be really helpful to understand. And this built on some earlier work that Neela Guha did when she was at IARC with Dinesh. And it's really, these types of approaches are super, super helpful, but having the cases is critical as a foundation and in order to do that. So Martin and I at the virtual SOT, which is 2021, had this poster where we were kind of summarizing some of the emerging lessons since the 2019 preamble. And I think you can go ahead and get the poster. It's on the Casey's website if you're interested in the details. But I just would like to say that, again, there were very few human biomarker studies for these agents. There had now been classifications that were based on the cases, not rocket science to take an agent that is genotoxic in multiple systems and say that it's possibly a human carcinogen. To me, that is not a huge step, but that is possible under the preamble. I think it lays the groundwork for the future. And these colors indicate the type of system. And I just would say for these more complicated, these cases over here, 6, 7, and 10, these are more complicated in terms of the biology. And working groups were really continuing to rely on in vivo animal tests for every time they went to strong evidence of those. And I think that's just a point to bear in mind. Things like chronic inflammation, it's not an obvious to get to a short-term in vitro test that's really going to reflect that. And again, the high throughput data, I don't want to trash on it too much, but we're waiting for that exciting moment with it. Then we had a little pandemic and I came back to the US and joined the academies. And one of the reports that came out recently was guidance to the IRIS program and also highlighted the cases, which recommending that they be used by the program, search and organize their mechanisms of evidence and really look at biological plausibility. So just to turn to some of the recent progress that people have been doing, I had the pleasure to write with Mary Schubauer Berrigan, an invited perspective, which I'd recommend looking at. I think some of the key questions that remain in identifying cancer hazards, of course, are around breast cancer, which is the leading cause of cancer death worldwide, and we know very, very few causes of breast cancer. And so Mary and I opined on that issue, and also tried to indicate that you can use the cases, you could do studies in female workers and in other situations that would really help clarify some of these issues. And I just would say other people have recognized the cases give you an opportunity to apply some machine learning, and Roel Vermeulen had a really nice one doing an automated network assembly, and some folks in the Monographs program also made a cute thing that will pull out your high throughput data. So I think some of these things are going to be very helpful, at least in the priority setting example. And I think if we still need to continue to develop best practices based on experience and continuing to advance the cases. So just some take-home messages to close. Mechanistic data can play a role in identifying cancer hazards when the human data are less insufficient. And you have to remember, expert groups around the world, their biggest concern is they miss something. So the KCs are a way to bring all the evidence to the table, and that's I would say one of their greatest utilities. But they do provide this basis for an objective approach. It's reproducible, it's transparent. That's what we need. That can build confidence. You can spend your own time making your own little wiring diagram if you'd like to, but this is now based on evidence. And this also lays groundwork for future evaluations, where these type of data can be continually relied upon, and can provide confidence about decisions. So many people to thank, IARC working groups who have pioneered use of this approach, all the IARC staff who encouraged us to continue working on developing them, many co-authors and also reviewers of these papers, and most of all, thanks to Martin, and thanks to all of you for listening. All right.